Okay, so now instead of rotating just an individual point, I'm actually going to rotate a polygon, in this case a quadrilateral. So I want to graph the image of the polygon after a rotation of the given angle, in this case 180 degrees. Again, that implies counterclockwise about the origin. Okay, before I do that, here's what I would suggest, and here's what I'm going to do is write down the coordinates of each of the pre-image points. So I have the coordinates of the pre-image listed, J, K, L, and M. And then since it's a rotation where the center is the origin and it's a multiple of 90 degrees, I can go back to my rules of rotations. Okay, the rule of rotations for 180 degrees is you start with the coordinate AB, and then that rotates to or changes to negative A, negative B. So this just tells me that each of the image points, you take the opposite of the x coordinate, you take the opposite of the y coordinate. So before I graph, I'm actually going to find the coordinates of each of the image points. J prime. Okay, so J was negative 2, positive 4. Take the opposite of each of the coordinates. Positive 2, negative 4. K prime. Positive 5, negative 1. L prime, positive 2, positive 2. And then lastly, M prime, negative 1, negative 1. Now I can graph each of those points in my coordinate plane. J prime, 2, negative 4. K prime, 5, negative 1. L prime, 2, 2. And then lastly, M prime, negative 1, negative 1. And then I could draw my rotated figure. This is the image. Every point in that quadrilateral was rotated 180 degrees. Okay. Especially since the angle of rotation was a multiple of 90, the center of rotation was the origin. Okay. Instead of having to draw each of my rays and then figuring out my 180 degree angle, I would use the rule of rotation for 180 degrees. Should be a lot easier that way.